Hi students, how are you? I hope we all are fine. Some students asked me to tell about the hybridization topic. That's why I choose this topic. Today our topic is hybridization. Hybridization. What is the hybridization? What are the important of this hybridization? We will learn now. Okay. In order to explain the characteristic geometrical shapes of polyatomic molecules, we use the hybridization. By using this hybridization, which purpose we use the hybridization? To know the geometry of the complexes. See, these atoms are methane, ammonia, water molecules. These are two different type of atoms combined to form a complexes. These atoms are these complexes have particular geometry, shape. How we get the shape? The valence electron overlap each other to get a particular shape. If you know the shape of these complexes, you know it is a stable or not. Okay. Who was first introduced this hybridization? Pauling. Pauling first introduced the hybridization. In valence bond theory, the complexes get stability. To get this stability, it undergoes hybridization. Okay. According to him, the Pauling, according to what is the definition of this definition? Hybridization is nothing but what? Mixing of orbitals. Mixing of orbitals. Which type of orbitals? Near same energy level orbitals. Same energy level orbitals mixed together to get equivalent orbitals is nothing but what? Hybrid orbitals. What is nothing but hybrid orbitals? A mixing of orbitals. Here there is no longer difference between the energy levels. Nearly same energy level orbitals are mixed together to get what? Equivalent orbitals, that is hybrid orbitals. This phenomenon is nothing but what? Hybridization. Are you clear, students? Hybridization. The mixing of same energy level orbitals to get equivalent orbital is nothing but hybrid orbital. The phenomenon is nothing but what? Hybridization, which can be defined as the process of mixing of suitable atomic orbitals of the atoms resulting in the formation of a new set of orbitals of equivalent energies and the shapes. See here, there are different types. sp orbital hybridization, sp2 hybridization, sp3 hybridization. What are the orbitals involving in this? What are the outermost orbitals involving in the hybridization? That we get different types of hybridization and different type of structures. What are the silent features of the hybridization? The main feature of the hybridization is the hybridization. We mix a certain number of orbitals. We all know that, not a number of electrons. See, this is the main important feature. Features of hybridization. Features of hybridization. In hybridization, first point is it involves the orbital. Okay, outermost orbitals involving in the hybridization, but not electrons. Involves only orbitals but not electrons. Okay. The second one is the number of hybrid orbitals form equal the number of atomic orbitals that we get hybridized. Okay, what are the hybrid orbitals involving in that? That only that much hybrid orbitals we get. The third one is only orbitals of similar energies can be mixed to form hybrid orbitals. Okay, I will write the second point here. The number of hybrid orbitals form how many we get that is equal to the number of involves, equal to number of orbitals involved. That involves. Okay. The third point is when orbitals of similar energies can be mixed. Similar energies, not large distance between the energy levels does not overlap each other. Similar energies get hybridized. Fourth one is the hybrid orbitals are more effective in the forming of stronger bonds that leads to the formation of more stable molecules. Why the complex undergoes hybridization? Because more stability. To get more stable molecules. To get more stable molecules. The hybrid orbitals are directed in space so as have a minimum repulsion between the electron pairs. Hybrid orbitals have minimum repulsion. Hybrid orbitals have minimum repulsion. These are the features of the hybridization. In this hybridization, only orbitals are involved but not electrons. The number of hybrid orbitals formed is equal to how many orbitals involving in the hybridization. Similar energy level orbitals are involving in the hybridization. What is the main purpose? To get the more stable molecules. The hybrid orbitals have minimum repulsions also. Okay. These are the features of the hybridization. What are the important conditions? Okay. The orbitals present in this valency shell of the atoms are hybridized. Most probably in complexes the outermost orbitals are involving in the hybridization. The orbitals undergo hybridization should have comparable energies, nearly same energies. A promotion of electrons are not an essential conditions prior to the hybridization. Sometimes in not only excited state electrons but ground state electrons also involving in the hybridization. It is not necessary that this only the filled orbitals are participating in this hybridization. Not only the filled electrons but also half filled and full filled also participating in the hybridization. Okay. Now coming to these are the important features of the important features are the orbitals present in this valency shell. Valency shells are involving in the hybridization. It has a comparable energies and also not necessary to the excited state. Sometimes ground state orbitals also involving in the hybridization. No need to not only the half filled, full filled and vacant orbitals also involving in the hybridization. Are you clear, students? Now coming to the types of hybridization. Types of hybridization. SP hybridization. In this SP hybridization, how many orbitals involving in the hybridization? SP. 50% S and 50% P involving in the hybridization. I will explain through the one example. See here. beryllium chloride. The atomic number of this beryllium chloride is beryllium chloride. Beryllium atomic number is 4. Electronic configuration is 1s2, 2s2. It is a ground state electronic configuration. Ground state. If it is go to the excited state, what will happen? 1s2, 2s1, 2p1. In we all are know, in p orbital we have px, py, pz. 1s2, 1s1, 1p. 1s orbital, 1p orbital. Here have unpaired electrons. These two chlorine atoms combines overlap these orbitals. We get this one chlorine atom, this one chlorine atom. Overlap with this s and p orbitals. We get sp hybridization. Sp hybridization. The shape of this complex is geometry is linear. This is linear geometry. Bond angle is sp2 hybridization. In this sp2 hybridization, one s orbital and two p orbitals involving in the hybridization. Orbitals are involved in hybridization. One s orbital and two p orbitals involving in the hybridization. Example for this complex is this sp2 hybridization is BCl3. Okay. The barium atomic number is 5. Electronic configuration of this barium is 1s2, 2s2, 3p1. It is a ground state electronic configuration. When it is go to the higher excited state, the configuration of this 1s1, 2p1, 2p2. See here. Px, py, pz. These three chlorine atoms overlap with these orbitals. We get sp2 hybridization. sp2 hybridization. Hybridization is sp2. The shape of the molecule is, geometry of the molecule is trigonal planar. 3 chlorine atoms, trigonal planar. Shape of the molecule is trigonal planar shape. This is sp2 hybridization. Now coming to the sp3 hybridization. In sp3 hybridization, how many 1s electron, 1s orbital and 3 p orbitals involved in the hybridization. 1s, 3 p orbitals involving in the hybridization. Example of this complex is methane. Methane, in this methane, carbon have electronic configuration. Atomic number 6. Electronic configuration of carbon is 1s2, 2s2, 2p2. It is in ground state electronic configuration. When it is go to the excited state, higher energy level, the configuration will changes 2s1, 2p3. Okay. Here full filled, this is half filled. See, these 4 half filled orbitals are overlapped with the hydrogen atoms. One hydrogen. hydrogen orbitals. What we get? 1s 3p sp3 hybridization. This is sp3 hybridization. The geometry of this complex is tetrahedral in shape. What is the shape of this complex? Tetrahedral in shape. What is the main purpose of this hybridization? By the hybridization we know the geometry of the complexes. If you know the geometry of the complexes, we are able to know the stability of the complexes. See here, I'll give one question here for alkenes and alkanes. Okay, see, write the C2H6, C2H4 and CH2. These complexes you write the hybridization, and each of these complex we write the hybridization. You will comment me first the answer. I will explain the topic. Who ask my doubt, that I explain first. Okay, write the answers of these three complexes. Comment me in a comment section. Thank you for watching. If you like my video, please give a big thumbs up, hit the bell icon and subscribe my channel. I hope you all understood this topic. See here, not only S and P are.
Thanks for watching.